Now we will start our class. So today is our last class in this semester, and the next week is your turn. Okay. So today I will show you how to use in the seaborn and to conduct analysis for the Taiwan data. And I already put the file into the Moodle. So if you need later, you can download from the Moodle. I will give you the Jupyter file and the slides file. And today we will using the Taiwan data, just the Taiwan clean data. Your final presentation, we needed to use in the Taiwan clean data. So today we will focus on this Excel data and to show you how to use in the seaborn to conduct the analysis. Okay, so I try to finish everything earlier because that is our lesson course. Okay, so today in the lesson week we show you the 6 plots. Okay, we can using the seaborn to conduct the 6 chart types, just like the bar plot, his plot, box plot, scatter plot, all the things. And today I try to using the Taiwan data to apply these charts in our Taiwan data. Okay, so as a beginning, later we needed to do these things. The first thing is we needed to import our package. Okay, that is really easy to know. And also we needed to set themes, just white grid. In the previous week we show you we can use in the white grid, dark grid, white, and the dark or thick. Okay, and the context we can set it up with a talk. What is talk? Talk is just for our presentation, and we can set up with a talk. But if you say you want that for the publication, you need to change another type. Okay, and also we needed to PD read Excel. So you needed to make sure our Jupyter file and this Excel file is in the same folder. Just like here, you can see I put these 2 files in the user. I can see the Excel file and my Jupyter file. So in my Jupyter, I can see these 2 files. So I just open the Jupyter, and then later I can run all the things. And for today, actually we define the 4 variable. Okay, just the gross margin, net margin, ROE, and the debt ratio. Okay, and later I will show you how to use in these 4 new variable and to do something. Okay, you know we already have over than 30 variable, right? But actually the 30 variables, that is not enough. So we wanna put more into our seaborn. Okay, so now please write down your code like this part. We needed to finish the first one, and then later I will show you the other things. Okay, so please finish this part. Going. But before we keep going, so we needed to move to here. Next week is our final presentation, right? And for our final report, all the reports is in each group you have 2 to 3 members in a group, right? But in the previous week, some of you asked me a question is we needed to present in English or Chinese. I think is we needed to present in English, okay, because that is an EMI course. And also we have so many foreign students, so I think speaking English, that is also a respect. Okay, so please present your slide in English. Okay, and by the way, do you have any other question about the final report? If no, we will go ahead. Okay, so now we have defined some variable, and also we import our Excel file, and we needed to do something. But before we keep going, I want to ask you a question is, do you know what gross margin, net margin, ROE, and the debt ratio are? What is this? Do you know this? If you know this, please raise your hand. No worry, I will not ask you any question. Okay, if you know these terms, if you hear about these terms, please raise your hand. Okay, I believe that most of you hear something about these terms. Maybe we don't know what exactly these terms do, right? But this term, if your final project is using this term, this is a little bit boring. Because when I say, oh, I want to discuss about the semiconductor industry, their ROE, you say, all the things I know. You want to talk about the R&D expenditures, We say we know they for sure they will put so many money, invest so much in their research and development, right? So is that possible to define a new term? For example, this term is not news. So how about R&D profitability? If today I give you a term is R&D profitability, is there anyone know these terms? I think maybe the most of you didn't hear about this term. But can you guess that? What's this idea? What's this concept? You just depends on your imagination and you can share your opinion. What's this term? Anyone can tell me? Anyone wanna guess? Yes?
I think it indicated how many money you spend on your R&D team, and how many product or how many market margin come back by the R&D department.
Okay, you're really careful to using the margin. Okay,
I'm
just.
kind of confused to how to make sure that this kind of profitability is from R&D department.
Okay, yes. This is a good idea. Is we just wanna treat these things like input and output. What is input? Input is our R&D expenditures. How much you put in research and development. And what is our return? Return is our profitability, like our gross margin or some things. Okay, for example, in here, so I wanna define R&D profitability like this way. Gross profit divided by R&D expenditures. So we know for each money I invest in R&D and how many gross profit I can get. Okay, so that is this idea. Do you agree with this point? If you agree with this point, please raise your hand. Okay, thank you. Some of you agree with that. If you don't agree with that, please raise your hand. No? If you still have the breath, please raise your hand. Okay. So why you don't agree with this point?
Because I think gross profit can be affected by all the department of the company. So it's hard to just use this formula to describe this kind of, you have a percentage, but it's hard to describe that it really means that the R&D profitability. To me,
That is a good idea because for a company, there has so many inputs. Maybe that is about their productivity. That is about their research and development. That is about their marketing. We can discuss about all the things, but why today you only focus on R&D expenditures? So I have a paper. It's talk about these things. I try to talk about the research and development expenditure and the gross profit, but I discuss about many industries. Some of the industry, there the two variables, that is a positive relationship. Some is negative. So we only talk about these R&D profitability in specific industry. For example, semiconductors industry, the gross profit and the R&D expenditure, their relationship is quite positive. So I try to use in the R&D profitability. So that means when we put more into our research and development, and that is highly possible to get more from in our returns. So that is about research and development profitability. So this is quite interesting, right? And maybe I needed to use in the pandas, I need to use in the NumPy before my SIBO. So for your final project, not only for a figure, that is not enough. If you only give the figure, I think the most of you will use in the same, quite similar figures, nothing special. So is that possible to find out some literature to create a spatial term, spatial variable? I think that will make your report more interesting. Just not only using our traditional variable. This is not interesting enough. But maybe if you think using these four variables, you can have a quite interesting angle, and that is also welcome. Okay, so please just depends on you. No worry about that. I just want to show you a concept. Sometimes the people do the things and they use in the same way. That will not make you become so outstanding. Will not make you so excellent. So that is not enough. And you need to know that you are the people who is so excellent because you are the student from National Cheng Kung University. So we try to do something different with others. Okay, we try to find out some other things to support your idea. So maybe you cannot define a new term, but maybe you can try to find out the literature. Like I have the variable A, variable B, what kinds of the things, what kinds of the new terms, new variable I can use. Okay, so you can define the new variable. And if you find out some literature to support your idea, please cite in the paper. Please cite in the paper to make sure that you have some evidence to support your idea. Okay, so that is just some concept I want to share with you, because that is just the critical things to make you become so special. Okay, so now we will move on our sixth chart on Taiwan data. So today we will using the figures, the charting plot into our Taiwan data. So at the beginning, we want to share with you is his part. It's just how to conduct the histogram. Okay, and I think the most of things you know, okay, but the first thing is DFROE, drop NA. Why we needed to do these things? Okay, I will show you, maybe in the ROE, this variable, some of the data is missing. So we needed to drop NA to delete some null data. Okay, so that is the first thing. And we needed to assign back to the ROE. And the second thing is we define this one. What's this meaning? Is we needed to make sure our ROE there maybe have some extreme value, or we will say that is an outlier， 就是它是一个异常值。我们有时候会说这个是极端值，那我们要把极端值拿掉。So we need to drop out the outlier. What is outlier? I just check with the data and I find out that if ROE is lower than minus 0.5, and I need to drop out it. And if ROE is higher than 0.6, I need to drop out it. So I just give the scope. Okay, I give the scope. So that is our new ROE. If I do this, and I will get the new ROE. Okay, so in here, I want to share with you these things. Because I give you all the data, so you will try to do like this way. The first one is ROE, and I will call ROE. And the second one is I will do these things. Is ROE. Okay, you can see at the beginning we have 1,800.3 piece of data, but now we only have 1,799 data. Okay, so we delete 4 data. Okay, so that is not enough. We needed to do this again. We delete maybe 30 piece of data. Okay, so we already drop out the outlier. So our data is so pure, and that will also make our figure become more beautiful. If you don't want to drop out the data, that will become a long table, a wide chart. Okay, so we need to make our user can easily to read our chart. Okay, and here is the plot figure is about how we just setting up with our figure size, and also his plot is just we put the ROE and the setting with the bins. KDE just like this curve is so smoothly, and we give the color and the edge color. Okay, that's just finished. But something different is this one, AXVLINE. What is AXVLINE? AXV line. AXV line is this one. Here has a dash. Can you see this one? Here has a yellow dash. Okay, that is AXV line. What's the thing we needed to do? We want to show up with the ROE median. Okay, so this line is ROE median. And also we needed to set it up with the color and a line style, dash dash. Okay, we just give the dash line. And also the label. What's the label meaning? Label is just here. Median is equal to 6.58%. Okay, so that is a label. But if you don't want to put the label, that is also okay. And if you don't want to share with AXV line, that is also okay. But when we show a median in here, and you will know the whole situation. Maybe all the data you can compare with your median. Okay, so that's the reason why we needed to put the AXV line. and also put the title, X label, and the legends. Okay, so in here, I will show you this one. So I give you the whole things. Maybe you can try to delete something, like maybe I cancel the label. So you will find out that label already be canceled. And I delete this one, nothing happened. So maybe you can try to do something on our code. Okay, and now it's your turn. Please try to using our code to run with your histogram. Okay, so when we already get a chart, we try to give more descriptions. So please not just show the person's figures, you also need to show your idea. For example, in here we can see that is a rescue, and we have the 5 to 10% ROE. Okay, the most of friends cluster around 5 to 10% ROE, and in here this line, that is about 6.58. So that is our median. So that is the most honest centuries than the mean tiers. Okay, so we can see the most of countries their ROE status. Okay, so you will show the other people that if today we wanna make our net income divide by total equity, and we will get the ROE. And the most of company their ROE is only 7%. Okay, so that is poor status. And the later ones is we still have some negative value, negative tail exists. Okay, so that is about our histogram, his plot. And the next one is our scatter plot. What is our scatter plot? Scatter plot is, I think that is the most interesting figures. Okay, but when we want to do these things, that is a little bit hard. Okay, why I want to talk about these things? If we put all the company's data in the figure, this is nothing special. But in here, I try to conduct some things interesting, like in today, maybe the most of foreigners, when they talk about the Taiwan, the first industry they want to talk about is about semiconductor, right? So we want to compare the semiconductor and the other industry. What's their difference? Okay, so in here, the first thing is I setting up with the plot DF is DF drop NA, and the subset I only focus on the revenue and the net income. Only focus on the revenue and the net income, and we wanna check with their revenue and the net income. The two things needed to more than zero. So we needed to make sure that is a positive numbers. Okay, so when we're using the query with these things, that is just about setting our condition. So we want to make sure all the value is over than zero. Okay, and the later thing, I think that is quite important, is lambda. What is lambda's meaning? Lambda's meaning is they just give a condition, just like our if and else condition. So if today your X is equal to semiconductor, and we will make your X become semiconductor. If not, just else, the other condition, we just set it up with other. So now in our data frames, we have a new column is highlight. So we want to check with plot DF, sector English name. So we want to check with all the sector English name. If today their sector English name is equal to semiconductor, so just give a label is semiconductor. If not, just put the other. So now we have the new column. This column is highlight. So highlight only have the two pieces of the data. One or two type of the data. One is semiconductor and other one is other. Okay, and the other thing is in this figure, the first thing is we needed to set it up with a query, and the second thing is setting up with a lambda. The third thing is this one, log. Okay, we want to switch from linear to log scale. We want to switch from linear to log scale. Why we needed to do this? Imagine that today we have maybe over than we have maybe 1,800 companies, right? But maybe there have only 10 companies. The number of employees is so many. Okay, but the most of company maybe they only have 50 employee or 30 employee. So that is a huge change. That is a huge change. So today we will try to using a log scale. A log scale. Maybe we can see here. Traditionally, when we talk about the linear scale, just like 1, 2, 3, 4, 5. If the most of companies they only have a 1 employee, 2 employees, 3 employees, just like that. But there has another company, just like maybe Honghai, they have 80,000 employees. So this is a totally different. So if we just using a linear scale, that is a little bit hard to represent their difference, right? But if today we are using a log scale, just when that is under the 10 employees, and that is the first label, and the 100 that is the second label, and the 1,000 that is the third label, and the 100,000 that is another label. So we just give the log scale. We want to change from the linear scale to log scale. So if today you're facing this situation, just your data spans multiple order of the magnitudes. So please change from the linear scale to the log scale to make sure your figure will have a pretty look. Okay. So in here I just changed that. I want to define the AX. AX is just our scatter plot. But our scatter plot, I want to define that their X scale and Y scale, all the things we want to change with a log. Maybe you only want to change one side, that is also acceptable. But in here, I want to change the 2 dimension. Okay, so that will become these figures. And when we needed to change that, just like your company revenue, we have a giant company, we have a tiny company, so we needed to change that. And like the headcount, maybe your employees number is totally different, and like the stock price and the website traffic, all the things. Okay, you needed to change from the linear to the log scale. And I think the most of 3 things is these 3. Okay, so the first one is we setting up with a query. We setting up with a query. So we only want to talk about whose revenue is over than 0 and whose net income is over than 0. So, but please notice here. Here I'm using the and. And is our condition. You needed to in these 2 conditions needed to be true, and we will run the code. Okay. If one is false, and they will not run this one. Okay. So revenue is bigger than 0, and net income is bigger than 0, and I will using this data. And later I define another column is highlight. And how to define that? I'm using the lambda. And finally, I want to switch from the linear to log scale. So this is about our scatter plot. So that is your turn. I will suggest you to run this code first, and you will change some small things. And when you try all the things, after that, please, maybe you can use in the other variable. Okay, and you will see the different situation. Okay, so now it's your turn. Please try to draw with your scatter plot. So you can see here when we talk about the Taiwan scatter plot in here, and the red dot is about our semiconductor, and the other is gray. So we will find out that there has a strong positive trend. So the net income is high relationship with revenue. That is a positive relationship. Okay, and also we find out that the spread is huge, and some points in here, some points in here. So the spread is quite huge. And also we can find out that the most of the semiconductor is above the lines. Okay, so that means our semiconductor, maybe we have the same revenue but have a higher profit. So the pricing power is quite great. Okay, so this is about our semiconductors. Okay, and later we will talk about the heat map. But before we conduct the heat map, I think we can take a 10-minute break, and later we will keep going. do you feel a little bit nervous about our next week, the final presentation? I think for my course is just want to make sure so all of you can learn something from this course, and I know this is quite challenge for the most of you because maybe this is your first coding course in your life or in your university. Okay, so no worry about that. You just needed to remember one thing: is just from the beginning of this semester, you don't know everything about you don't know thing about the coding. But in today's, you can already using the Python to have some plot or some figure, and you can try to describe or analyze the figures. This is quite enough. This is quite good. Okay, so you need to satisfy with your status. So please no worry too much. Okay, please no worry too much. Okay, but I think maybe after the course you needed to organize what the thing we learned in this course. Because our course is, I organize it and I provide the material for you and I give you each week what the thing I want to deliver for you. But you need to organize that why I want to put something in the beginning of the semester, why I want to put something in the middle, what the things I put in the end, and how to integrate it with all the things. Okay, and by the way, your final project, maybe you can put in your CV. Your CV is not just says, oh, I am really good at Python and I can use in the Cbone, Pandas. This is not enough. Sometimes you need to put your works in your CV to show the other people, say, oh, I have the project we using the Python and to analyze the real world data. So this is quite different with the other traditional Python course. Okay, so I hope that you can benefit from this course. Okay, this is my idea. So we will keep going. Now we will enter into the heat map. Okay, the left hand side is our traditional heat map, and the right hand side is for our Taiwan data. And when you see these figures, do you observe some things from this figure? Is there anyone can tell me why the two figures is quite different? What's the difference? What's the difference? Wanna guess it? Why the two figures is quite different? Okay, now I wanna give you you can discuss with your peers, 2 to 3 for a group. And later I wanna ask for your idea. Okay, why these two figures is quite different? You needed to tell me the reasons. So you can 同学讨论哦. So you can discuss with your peers now. I give you 3 minutes, and later I will ask you. right. So is there anyone can tell me what's the difference? What's the yes?
Object with the type. Comparison with the type.
Comparison with the type. 你先用中文没关系。
是它有12个项目去，然后对应的是实际。
Okay. Oh, this is about the 12 months and compare with the.
You can see the trend.
Oh, we can see the trend.
Yes.
Okay, and in here, what the thing we can see?
You can compare with yourself or others to see their relationship.
Oh, the relationship between the two variables, the right hand side.
Maybe it's with the others or yourself. So you can see the line.
Okay, in here we can see the 1, 1, 1, 1, 1.
You can compare with yourself, so the relation will be 1.
Yes.
When
Because the revenue compared with the revenue, so this will be 1.
yes.
And the revenue to the net income with the net income, this will be 1. Okay. So when the number is over the maybe 0.7 and this is a high, they have the good relationship. Okay, really positive relationship. Any others? Yes? The left hand side? Continue for what? Oh, continuous. Okay.
The right side, the data right side
Is what?
is individual.
Individual. Okay, so you think the data in here is continuous, and here is individual. So maybe they don't have any relationship, but in here they have a relationship. So this is just have a gradient color in here. Okay, any others? Yes.
That's where it's more basic and simple to understand. Just the amount of the area customer going by the time and the months. On the right side indicate that the Pearson relationship of different indicators relationship. So as you can see, maybe gross profit compared to the net income is 0.79, so 97%. So it's a really high positive relationship. Like gross profit increase and net income increase. So you can see different indicators, the correlation in the right side.
Okay, we can understand the correlation. Okay, thank you. And you?
The category is the different categories like month and year. The right one is about like
Okay, the left hand side is about the month and year, and the right hand side is about the different variable and their correlations. Okay, so thank you for your ideas. But I want to ask you another question: is why here has a red color and here is only the white one? What's this meaning? What's this meaning? Yes.
Maybe the two variables don't have the similar component.
Okay,
You
so.
can see the employee with the gross margin, they don't have the 他们是指不一样的东西。
Okay, so when we maybe from the revenue, net income, gross profit, total asset, and to total equity to the employees, these variable they have a really positive relationship. But for others, they don't have a strong relationship. So in here we can see the color in here is so dark, and in here, this is just a white color. So this means they don't have the strong relationship. Okay, so that is heat map. Heat map. When the color becomes darker, and we will know the relationship will become so strong. Okay, so that is heat map. So maybe before you analyze something, maybe you can try to have a heat map with your own variable. You can pick up some variable and try to understand their correlation. So at the beginning, I wanna choosing the 10 variable. Okay, I just pick up 10 variable, and I using the DFCOLS and the COR. COR is just correlation. That will help us to conduct the correlation. But here you needed to set it up with a numeric only is equal to true. Why we need to set it up with this? Because in here we have the 10 variable. Maybe some of them is string or the Boolean type. But when we talk about the Boolean type or string their correlation, that will have error. Okay, that will encounter the error problem, error issue. So we needed to deal with that. We needed to set it up with numeric only. Even you have some variable is string or Boolean type, that will skip all the error. Okay, so you need to set it up with numeric only. 就是说，你有时候用布林值，有时候变数它是布林值，或者是字串，它就会导致它在算这种 correlation 的时候会出错。那我们为了不要让错误出现，所以你必须要去设定这个东西。Okay, and then the other thing is we need to understand their relationship is we setting up with all the correlation. And if the correlation is 1, that is a perfect positive correlation. If it's over than 0.7, that is a strong positive. Over than 0.3, that is a weak positive. Sometimes that is also a weak negative. So we can use this value to understand the relationship between the variables. Okay. So in here, it's about we pick up the variable. You can just choose in what the variable you wanna discuss, and also we conduct the correlation, and we set up with our figure. The figure size is 10.5 and 7.5, and we just set up with all the key map. Okay, all the key map. Okay, and the what is x ticks is here. We need to change their rotation. So I can change in here. The rotation will change to our label rotation. Okay. So maybe you can just depend on this key map and try to have your code. Okay. And all the things you can just define by yourself, like the Vmin and the Vmax. I just define it from the -1 to 1. So in here you can see the -1 to 1. Okay. So the parameters you can define by yourself, and I also set in the centers in the 0, and the C map is RDGY with R. So maybe that is just like our color bar. Okay, I just using the red color. Okay, and also I wanna deliver that our correlation is using the Pearson R. Okay, so I also put the label in here. Okay, and the ANNOTKWS is just about the annotation. It's in here. Okay, annotation in here. Maybe not only setting for your phone family, but also you can set it with the phones, their size or their color. So you can set it up with a different parameter. But in here, I only set it up with a size. Okay, so this is about our heat map. And now it's your turn. You can try to finish your heat map. So please look at here the heat map. Okay, the later one, this is we needed to illustrate what the things we see and we find out from this figure. The first thing is there has a 2 cluster. The first cluster is here, just from the variable revenue to variable employee. All these variables, they have a relationship, right? But the second cluster is here. Gross margin is highly related to our net margin. Okay, and our ROE and the debt ratio, they have their own story. Okay, they don't have any relationship with other. So that is about ROE and the debt ratio. Okay, and also you can using the relationship between the other variable to tell the other story. Okay, this is just depends on you. So that is about reading the Taiwan email. Okay, and I think these 3 figure is the most interesting figures. Okay, but besides this, I also wanna show you the other thing is bar plot and the box plot. Okay, so the first one is our bar plot. Okay, how to analyze our bar plot? If we just put all the sectors into our bar plot, this is quite boring. So in here, I just using the DF sector English name is value count, head 10. What's this meaning? If we set it up with head 10, that is means we depend on the top 10 company and to show that. Okay, so we depend on here and to show the top 10 company. Okay, and the second one is GM is equal to DF sector English name is IN top sector dot copy. So we wanna copy the something from the top sector to the GM as a new data frame. Okay, so they just wanna check with the sector English name. If today, for example, now we have a 1,800 piece of data, right? So we wanna check with all of the companies their sector English name. If their sector English name is equal to maybe the other, okay, we will choose that. We will choose this figure. If that is equal to plastic, we will choose that. So we will choose that. Okay. So these things, ISIN is just like if and else. But when we're using if and else, that is only evaluates one condition. But in here, we can evaluate 10 condition. Because in here, we have 10 industry, 10 sectors, right? So that will help us to evaluate if their sector English name is equal to one of these 10 sectors. We will copy this data into our GM. So in here, I can show you the GM plot. Okay, in here, the first one is top sectors and the value count. So the top 10 is this. Okay, and later I wanna check with if the data their sector English name is equal to this 10, and we will copy that into the GM. So GM is a new data frame like this one. So how many data we get? In this 10 category, we get the 1,182 piece of data. But totally we have 1,800 data. Okay. 这个在做什么？这个在做的事情就是我们先去找到说前10大产业。那针对于这前10大产业呢，我们去判断我们的1800家资料里面有多少是属于这10大产业的。所以我们用的事情是 ISIN， 然后去确定我们的 top sector。只要它等于我们的这里面的其中一个产业，那我们就会把它整笔资料 copy 下来。OK。那一笔一笔抠到最后，我们发现我们抠了1000多百笔资料，1182笔资料，所以这就是我们目前在做的这个 GM 的动作。Okay, and when we finish GM, and we will keep going, is we wanna set it up with a gross margin. We wanna make sure our gross margin is larger than minus 0.2 and then not higher than 0.7. So I do another thing. It's our new GM. Okay, so in here, I also wanna drop out with the outlier. Okay, so you can find out that now we only have the 1,135 piece of data, but in here we have 1,182 data. So we drop out the 50 outlier in here. Okay, and when we finish these things, and we will show you the whole thing. We just put the thing into the bar plot, and we will see the result like this way. Okay, so that is about our bar plot. Okay, so maybe it's your turn. You can try to step by step to understand what the thing we do. Oh, by the way, here I also using an order. Order is I just depends on the gross margin. I try to calculate each sector their gross margins mean, just their average. And I will sort the value and to a list. So in here I will have the orders. Okay, so from the smaller one to the big one. Okay. Please look at here. these figures depends on your experience and depends on your knowledge. Can you see something interesting from this figure? We talk about the gross margin across in the 10 sectors. Okay, and we get this kind of the result. And is there something different or something special? You will find out that in Taiwan, the electronic and the computer industry has so many sub-sectors, right? But in here, which one is the best one? Is biotech and medical. Maybe if we don't show you this figure, you will consider the semiconductor is the best one, right? And also you can see the difference is quite huge. The difference is quite huge. Okay, it's just like maybe have the 8 or 9% in here. So the biotech and the medical, the gross margin is quite high. And the second one is semiconductor, and the third one is also quite surprising. It's building material and construction. Okay, so maybe you can try to find out the job from these kind of the sectors. Okay, because they have a gross margin, but I don't know they have a good care for the employee or not. Okay, this is also a critical issue. Okay, so we will run the final one. Okay, in this semester, our final one. Okay, it's about the. I want to show you with a box plot. Okay, the box plot. You will find out that I just want to do the same thing again. What's the thing I need to do? I choosing the sector. I always choosing the sector. In here, I using the picks. I choosing the sector. This action is quite similar with here. COLS, we're choosing the variable. And in here, we choosing the sector, the top 10 sectors. And in here, I choosing the 3 sector, okay? And also, I wanna using the sector ISIN thick.copy. So what's this meaning? I also wanna check with our data frame how many data is from these 3 sectors. So in here, I will show you this one. How many data we have? So we only have a 349 companies from these 3 kinds of the sector. One is semiconductor, and second one is biotech, and the third one will be the iron. Okay, so it's these 3 one. And also we have a figure, and we put our X is our sector English name, and Y is their gross margin. And I also using the HUE, the sector name, and try to classify them. So we will see the figure like this way. Okay, so this is quite easy to understand their gross margin. For the biomedical is in here, and the semiconductor is in here, iron steel is in here. So you can see the difference in here is a little bit larger than semiconductor, right? So their scope is quite wide. But for the iron and steel, this is so narrow. Okay, so this means the most of the company from this sector is quite focused. Okay, their gross margin is quite similar. Okay, so this is our final picture. So this semester we will end in here. And I think in this semester this is my first time to try to combine with real business data with Python. I know that is quite difficult for the most of you, but if we don't do this, that is just a normal Python course. What is a normal Python course? Because for my understanding, I think each course for the different department need to have the specific meaning. 就每一门课，即便是一样的课名，在不同的系它都应该要有不同的意义。我不知道你们有没有理解我正在讲的这句话？这样 ，For example, a Python course for the computer science department, for the information management department, for business administration department, they need to have the different specific meaning. But if today we want to have a Python course in the Department of Business Administration, what's the thing we need to do? Oh, we try to make our talent, just all of you is our talent. We try to make all of our talent have a skill, can analysis with business data, and using your business knowledge to do something. So that is the only way can show our difference with others. But if today I ask you to use the Python to conduct big data analysis, this is a little bit hard to show some difference with computer science, right? But if today we can show something different with business data, I think that is the only way we can prove our excellence. Okay, so I hope you can know what I talk about, and I also hope you can learn some Python skill and have more breadth with your coding skill. Okay, so no worry about all the things, and wish you have a good future, and wish you have a good success semester. Okay, and today I will end here, and next week please don't forget for your final presentation, and see you next week. We will end here. Bye bye.